All right, 2.3, postulates and diagrams. So let's first review some concepts. Find the angle measure. So 1 is a supplement. So remember, supplement means 180. Here's a quick way I remember it. Is C comes before S in the alphabet, 90 comes before 180 numbers. So supplement is 180, complement is 90. That will help us keep it on track. So angle 1 is supplement of 2. That means they both add up to 180. And 1 is 32, so we're just going to do 180 minus 32, which will give us 180 minus 30. You can do this in your head. You don't need a calculator. 180 minus 30 is 150, and then minus 2 more is 148. Number 2, 5 is a complement of 6. 5 is 59. That means they add up to 90. So 90 minus 59 equals, so 90 minus 60 would have been 30, okay? But we didn't take all the 60, so it's 31. 31 plus 59 equals 90. All right, BD, this ray, BD, right here, bisects ABC. So it bisects means it cuts into 2 equal parts, which means this is equal to that. So we just set it up like that. 6x minus 9 equals, that's a weird 2, but okay, we'll keep it. 2x plus 19. So I'm going to subtract 2x from both sides. Okay, I'm actually going to add 9 to both sides right here. I can do that in one line if I want to. That gets rid of that and that. So 6x minus 2x is 4x. And 19 plus 9 is 28. And when I divide by 9, divide by 4, x is 7. That's not what it's asking for. It wants you to find the measure of these angles. So I have to plug the 7 in here, technically and here, but really or, because they're equal. So if I just do one of them, 2 times 7 plus 19, that's 14 plus 19. So that is going to be 33 degrees, right? So ABD and CBD are both 33 degrees. And remember, if it would have asked you for the measure of angle ABC, it doesn't. But if it did, that would be 66 degrees. So always pay attention to what it's asking for. All right, you're going to just do this. If you want to do it on your own, you can. That's okay. Or you just listen. When you draw a diagram, it's important that you include sufficient information in the diagram. Determine which of the following statements you can assume to be true. All right. So all the points are coplanar. Well, if the gray sheet, the gray box is our plane, then all the points on there are on the plane. That's true. D, G, and I are collinear. Well, these three appear to be in a line. They look like they might be in a line, but we don't have a line going through them, okay? And if you look at a certain angle, I looks like it could be slightly off. We're not sure, okay? So since we're not sure, we have to say false because we cannot assume. A, C, and H are collinear. Well, A is here, C is here, H is here. They are on the same line, so that's true. EG and AH are perpendicular. Right, EG is right here. AH is this big long line right here, and since we see that symbol, we know it's true. And then BCA and ACD are a linear pair. Well, BCA is right here, ACD is right here. They do form a straight line, so it's true. Okay, so here's some stuff we're going to just use in geometry. Postulates. Postulates are just things like that we know to be true. So the 2-point postulates. Through any 2 points, there exists exactly one line. Okay? So basically you connect any 2 points with a line. And then a line contains at least 2 points. Those two go hand in hand. If 2 lines intersect, they intersect at exactly 1 point and 1 point only. Again, these are just kind of common sense concepts. The 3-point postulates. Through any 3, and it's very important here, non-collinear points, there's exactly 1 plane. And a plane contains at least 3 non-collinear points. Again, those go together. If 2 points lie in a plane, then the line containing them lies in the plane. And then, as we talked about before, if 2 planes intersect, they intersect on a line. All right, state the postulate illustrated by the diagram. So you see crossing lines, and you see crossing lines with a dot. So if 2 lines intersect, then they intersect at a specific point. That's called the line intersection postulate. And mathematicians are not very creative, so it's kind of like self-explanatory. The 2 lines intersect at a point. All right? If you have 2 planes, and then you see this red arrow here, that is basically saying if the 2 planes intersect, they're intersecting at on a line. So that one is called the plane intersection postulate. Not very creative. All right, use a diagram to write examples of each. The plane point postulate. All right, so remember the plane point postulate says a plane contains at least 3 non-collinear points. So we have B, actually we only have 3 points here, B, A, and C. Which plane are they in? Well, they're on plane P. So we would say plane P contains 3, this is very important, non-collinear points. I'm going to abbreviate here. B, A, and C. And then the plane line postulate, which states if 2 points lie in a plane, then the line containing them lies in the plane. Well, the only line we have is line N. So we would say something like this. Points A and B, also known as line N, are in plane P. So line N is in plane P. So since the points are there, the line is there. Again, kind of common sense. Sketch a diagram showing TV. So I'm just going to write there TV intersecting PQ at point W, and here's the important part, so that TW and VW are equal, which means we need this point W to be a bisector. So PQ, again, segment, not a line, looks something like that. All right, example 4. Which of the following statements cannot be assumed? A, B, and F are collinear. Okay, well, here's A, B, and F. Well, that can be, you can see they're on the same line. E, B, and D. Well, here's E, here's B, here's D. All right? We cannot assume that one's true because we don't see a line. All right? Line AB is perpendicular to plane S. So line AB, which is right here, is perpendicular to plane S. That's this plane right here. We know that because of that symbol right there. So we're good. No assumption. We know it. CD, line CD, which is this one right here, is perpendicular to plane T. Well, since we do not see a symbol, we don't know that for sure. And last but not least, AF, which is right here, intersects BC at point B. Well, we can clearly see that, not to mention we have the letter B in both of those. All right? And that is it.